this problem is being extremely straightforward with you with what it wants you to accomplish. And very oftentimes, mean value theorem for definite integral problems are oftentimes straightforward with you when they tell you that you need to apply this rule. So this problem is asking us to determine the x value of this given equation on this specific x interval here that makes this mean value theorem for definite integrals true. So the first thing we got to know is what the mean value theorem for definite integrals is, right? So MVT for definite integrals. You know, these notational definitions here of these theorems, right? They oftentimes look crazier than what's actually happening inside them. What this is saying, what it says is the average value of an equation, which you know what that formula is. That's 1 over b minus a, the integral from a to b of whatever your f of x dx is. That's a formula you need to know just in general, the average value formula. What the mean value theorem does is it sort of extends this idea and says, okay, well, not only can you tell me that that's an average value there, but I know that there has to be an x value here. They call it c. There's got to be a c value that I could plug in there that's actually going to equal that average. And they tell us that we're guaranteed that that c value has to be in between -1 and 2 in this situation. So the average value between -1 and 2, there's got to be some x value, some c value that lives inside there that equals the y value, right? Which kind of makes sense. Like, it's hard to have an average value if it doesn't exist in the actual problem. So first things first on this is we're just going to go and do a standard little average value setup. So on this problem, you would say, okay, my average value is equal to 1 over b minus a. So ours is going to go from -1 to 2. So that'll be 2 minus a minus 1 of our f of x. So 3x squared plus 10x minus 7 dx. So now we just need to take that antiderivative down a chunk at a time to find our average value. So doing the fraction up in front, we get 1 over 2 minus a minus 1. So 1 over 2 plus 1 gets us 1/3. And then we're going to have to multiply that by the result of this antiderivative. And what you're looking at there, that's just a straight up definite integral. It's a bunch of stuff being added and subtracted, and so we're just going to be applying our power rule here. So the power rule says add 1 to the power, and then step 2 of that process is divide by the new power. So working our way through this a chunk at a time, we're going to add 1 to the power. That's going to get us 3x to the third, divide by that new power, plus we've got an unwritten 1 on that x. We add 1 to the power. That gets us 10x squared, divide by the new power. And then the antiderivative of a number by itself, when we were taking derivatives, numbers went away. When you're undoing derivatives, taking antiderivatives, they gain a letter back. So that's going to be -7x. And because this is a definite integral, we would say evaluated from x equals -1 to x equals 2. To finish up evaluating that out to get your definite answer, a number out of that, you apply what I just call the top minus bottom method. So we're going to take the top value, plug it into that equation, and subtract off of there the bottom value plugged into that same equation. So we're going to get 1/3 times, and now we're going to, this whole thing needs to get multiplied by 1/3. So we'll plug in the top value first. You know, if you can, go ahead and simplify these equations. The 3's will cancel out there. The 10 and the 2 will cancel out, leaving us a 5 on top. So plugging in now, plugging into x third, the top value. So 2 to the third plus 5 times, and then 2 squared minus 7 times 2. That's our top value, subtracting off now the bottom value plugged in. So plug a -1 everywhere into that equation. So -1 to the third plus 5 times -1 squared minus 7 times -1. And then remember, all that stuff, whatever you get out of there, is going to get multiplied by 1/3. So we get out of here 1/3 times, and then inside there, all that stuff in orange, pop it into your calculator, do whatever you got to do, all that stuff equals 3. And so our final answer for the first part of this, our F average, is equal to all of these things. Our f average, our average value of this function is equal to 1/3 times 3. So our average value is equal to 1. So right now we know the y value of our average value. And what we do to finish this out is we need to now just go find the x value that makes that true. So this is really just an algebra problem. You're going to take your average value, 1, and you're going to set it equal to your original equation. That's how we find the x value we're looking for. So we want to know, when does this equation equal 1? To solve a problem like this, anytime you've got a power of 2 or greater, the process is usually the same. You need to get this thing set equal to 0 and then factor it. So we start off, we're going to subtract 1 from both sides to get it set equal to 0. So we get 0 equals 3x squared plus 10x, and then -7 minus 1 is going to get us -8. Next move is to factor this thing. You know, if there was a nice, clean, easy way to factor, I would be a millionaire right now, because nobody really is very good at it, right? Well, you got to get good at it. If you're going to do well on this test, you need to be able to factor really quickly. We could run through the quadratic formula right now, but really that's a time suck that you don't have the luxury of doing usually on an AP test like this. So I recommend, you just get your factoring skills down, because you're going to need them. So here we're going to factor this. This is going to be 3x times x is going to get us at 3x squared up front. We need to make a positive 10 out of here, and from a so I'm going to have 4 on this is going to get me there, and then -2, because -2 times 4 gets me -8. So I end up with 12x minus 2x gives me 10x. The reason that we factor, right, is because now we can take and set each one of those little chunks individually equal to 0 and solve those little math problems. So we know that 3x minus 2 equals 0 is a possibility, and x plus 4 equaling 0 is a possibility. And we just keep following along the algebra path here. So solving for x. So we add 2, we get 3x equals 2. And then go ahead and divide by 3, and we get x equals 2/3. That's a possibility for the c value we're talking about. And then we go and just do the other one, and we get -4, we get x equals -4. That's my other possibility. To see which one is the one we are guaranteed to get, the one that fulfills this, that one has to live between -1 and 2. Well, -4 does not live between -1 and 2, so that's not our answer. 2/3 does live between -1 and 2. So the x value, the c value, that we are guaranteed by the mean value theorem for definite integrals is this c value of 2/3, x equals 2/3. Remember, all that's really happening here is this is saying that your average y value has to equal your equation at some x value. So set the two values equal to each other and go solve that equation to find that specific c value. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.